Start whenever. All right. Hello. Welcome back to another Mathcounts meeting. Today we're going to finish 2016 state, and then we're going to move on to 2016 nationals. So let's just go ahead and get started. I think we're on the last question of target, right? Yeah, we're going to do team. Yeah. Yeah, we're on the last question. The polygon shown here is constructed from 2 squares and 6 equilateral triangles, each of side length 6 units. This polygon may be folded into a polyhedron by creasing along the dotted lines and joining adjacent edges as indicated by the arrows. So like that. And then what is the volume of the resulting polyhedron? Express your answer in simplest radical form. All right, so we're gonna fold this polygon. Basically, it's gonna like go over these dotted lines, and these arrowed edges are going to be like connected together in the 3D shape, and we want to find the volume of that shape. Well, if you think about it, if we fold these two things together, we're gonna get two square pyramids, right? So then we just want the volume of the 2 square pyramids. So we know that the side length is 6 units, and we know that these are equilateral triangles, right? So if we just get the base of the pyramid is just going to be the area of the square, right? So that's just 36 units squared. And then if we just find the height, we can multiply by this and divide it by 3 and multiply by 2 because we have 2 pyramids, and that'll be our answer. So we just need to find the height, right? So we're gonna have a pyramid thing like this, and we want to find the height. So we know that this is half of the side of the half the side of the square. So this has to be 3. Or we can use the diagonal of the square and this, but whatever. We can do it either way. Okay, so we know that this side is 6, and these are equilateral triangles, so this has to be 6. And we can draw a line here. So we know that this is an equilateral triangle, so then this is 30 degrees, this is 60 degrees, and this is 90 degrees. So then that means that this side is 3, and this side is 3 root 3. Just from a 30, 60, 90 triangle from there. And then we can just find the side by the Pythagorean theorem, right? So that's just going to be 27 minus 9 rooted, which is 18 rooted, which is 3 root 2. So this is the height, right? And this is the area of our base. So then we just do 36 times 3 root 2 times 1/3, and that's the area of one of our square pyramids. So this is just 36 root 2, and then we multiply by 2 to get both the volume of both pyramids. All right. Where is this? 72 root 2. That's your answer. Okay. Let's move on to team. Should be right here. Yeah. The end of each blade of a ceiling fan is 2 feet from the center of the fan and makes 3 full rotations each per second. Given that there are 5,280 feet in a mile, what is the speed in miles per hour of the end of one of the blades? Express your answer as a decimal to the nearest tenth. All right, and you have calculators in team, by the way, and target. Yeah. So we have a ceiling fan. The end of the blade is 2 feet from the center of the fan, so it's going to be like that, and the blades are, I don't know, just like that. And it makes 3 rotations per second. So we want to find the speed of this, right? So we should find the distance that this travels like per second. So it's going to travel in a circle around this fan, right? And it's going to be a circle with the radius of 2 feet. So it's going to travel around the circumference, and the length of the circumference is just going to be 4 pi feet, right? And then it makes 3 full rotations per second, so it's going to go through the circumference 3 times per second, or it's going to travel 12 pi feet per second. All right, so we already have the speed. Now we just need to convert it, right, to miles per hour. So just use dimensional analysis. We have 12 pi feet per second, and then we're given that there are 5,280 feet in a mile, so we put feet in the denominator like that. And then we want hours, right? There are 3,600 seconds in 1 hour. So now our units cancel, and we have miles per hour, and now we just do the now we just calculate it. So if you do this on your calculator, you'll get 25.7 miles per hour. You want it to the nearest tenth, which that is. Yep. And yeah, our answer is 25.7. A, B, C, D, and E in the decimal representations, 0.ABC and 0.DE represent the digits 1, 2, 3, 4, and 5 in some order. What is the least possible difference between the numbers 0.ABC and 0.DE? Express your answer as a decimal to the nearest thousand. So you want the least possible absolute difference between these two numbers. A, B, C, D, and E are all from those first 5 digits. So if we want the least possible absolute value difference, we're gonna want the tenths values to be 1 apart, right? That should be pretty obvious. Like, you know, if you like those are essentially like the biggest numbers, like deciding those. So you want those to be as close together as you can, which is just making them like 1 apart. But if they're 1 apart, you can take a lot of combinations still, right? So you still have to think about it a bit more. So the best way would be to make like these numbers as big as possible and these numbers as small as possible, or like E has to be like as small as possible, and D and A have to be 1 apart, and we want to make B and C like as big as possible, right? So why do we want to do that? Well, the bigger B and C is, then okay, like if we like assume that A is our smaller number, where we have A and D 1 apart, and D is our bigger number. So then we want B and C to be as big as possible, to be closer to D, and we want E as small as possible to be closer to A, B, C. And why do we make A the smaller number and D the bigger number? Well, because A has an additional C at the end, right? Which makes it like you can make it bigger than D, right? So and it's better to make the smaller number bigger because you want them to be as close as possible, right? Okay, so hopefully that made sense. So if we want B and C to be as big as possible, we want them to be like 5, 4, right? And we want E to be as small as possible. Well, we want it to be 1. And we have 2 and 3 left over, which is good because we needed these to be 1 apart. So everything fits here. So this has to be the best numbers. So then we just, you know, take the difference. And that should be our answer. So we have 0.056, and that's our answer. Oh, anything you wanted to add to any of those, Bill?
Mm, nah, I mean, all of those, there's not really something that complicated. It's more just you see one thing and then the rest is very simple. So,
Okay. Approximately 70.8% of Earth's surface is covered with water, the rest is land. It is said that Mars, whose surface is covered entirely with land, has approximately the same amount of land as the Earth. based on this information, what percent of Earth's radius is Mars' radius? Express your answer to the nearest one. All right, so one way you could do it is just do algebra. We can say RE is the radius of the Earth and RM is the radius of Mars. So the volume, or okay, not the volume, the surface area of the Earth is going to be 4 pi RE squared, right? And we're told that 70.8% of this surface area is water, but we're dealing with land, right? So we want to take 1 minus 0.708 of this. So if we take 1 minus 0.708 of this, we got the area of Earth's land. And we're told that this is equal to Mars's area of land, which is just and we're told that Mars' surface is covered entirely with land, so that's just the surface area of Mars, right? So then we have this. All right, so we can cancel out the 4 pi's here. So we want to know what percent of Earth's radius is Mars' radius. So you know, we could square root it. We could square root both sides. So then we get, whoops. Then we got RE times the square root of 1 minus 0.708 equals RM. And then this is just going to be our percent, or actually, what percent of Earth's radius is Mars' radius? So this should be our answer, right? 1 minus 0.708 square rooted. And I got 0.54 as this, and so this is just 54%, right? That's the nearest whole number, and our answer is 54%. So anything you want to add on to that, Bill?
Right, like last time, it's like what I've said before. This is just, this is you're turning two-dimensional, which is, surface area, into one-dimensional. So you're just going to square root that. Yeah.
Yeah. So this is like a two-dimensional scaling, right? So if you wanna look at the one-dimensional scaling, you just square root it, and yeah. All right. Billy wrote a sequence of 5 numbers on the board, each an integer between 0 and 4 inclusive. Penny then wrote a sequence of 5 numbers that measured some statistics about Billy's sequence. In particular, Penny wrote down the number of zeros in Billy's sequence, then Penny wrote the number of ones in Billy's sequence, and then the number of twos, the number of threes, and finally the number of fours. It turned out that Penny's sequence was exactly the same as Billy's. What was the sequence? Express your answer as an ordered 5-tuple. All right, so what is it saying? It's saying we have some 5-number sequence. Let's just use I don't know. I don't know. 1 1 0 2 4. Okay. And then there's a sequence that describes this sequence, which is the number of zeros, the numbers ones, and so on. So we have 1 0 in this. We have 2 1s in this. We have 1 2 in this. We have 0 3s, and we have 1 4. And we want to make these two sequences the same. And once once they're the same, whatever that sequence is, that's our answer. All right, so this one, you can find some information about it. You can find some information about it first. So, you can first note that the numbers in your statistical sequence has to sum to 5, right? Because they're describing all of the like the number of numbers that are in here, right? Like the number of like certain digits, right? But we're finding like we're looking at like this entire sequence if you sum them all together, you're summing like the frequencies of all the digits by themselves, which if you do, then it's just like all of the digits, right? But like how many digits do you have in total? It's five, right? We have a five digit sequence. So that means our statistical sequence, um, its sum has to be five, right? And if this sum is five, then that means our starting sequence also has to be five, right? Like because they have to be the same. So that's one thing to start off with. And then you can see that you can't have any fours in your sequence. Why? Because I mean, if you just like test some stuff out, if you have four, remember we said our sequence sums to five, right? That means we have to have three zeros and a one somewhere, right? Anywhere. But if we have three zeros and a one, then um, our statistical sequence can't describe that, right? Because we're gonna have three zeros somewhere. I don't know, anywhere. So our statistical sequence has to start with a three, but we don't have any threes in this sequence, right? So it's impossible to match them together. So we can't have any fours. So now we know our sequence can only have zero, ones, twos, and threes. And you can also test three out. Three doesn't work like anywhere. I don't know. Yeah. Um, how do you test three really? I don't know.
Um, you,
Okay, testing like your three case. So one case is if you have three and two and the rest are zeros, and then another case is if you have three and two ones and the rest are zeros. So in the three and two and three zeros case, well, you have three zeros, right? So your statistical sequence must start with three. So then your sequence must start with three, right? Um, and well, okay, you have one, two, right? If you have one, two, then you're gonna have a one in here, but you don't have any ones in there, so that's impossible. And then uh, three, two ones, and two zeros. Well, you have two zeros and two ones, so they have to have twos, but you have no twos in this sequence, so that's impossible as well. And that's all you can have with threes, right? So you can't have threes either. So now what? You know that you just have one, twos, and zeros. So then you can just try some stuff out. Um, I don't know. You want to give me a sequence, Bill, of one, twos, and zeros? I don't know.
one,
Okay, so you obviously can't have three of any of these, right?
right.
Because you can't have any threes or fours. So maybe we just try two zeros, two twos, and a one. Now let's think if this can describe itself. Well, we have two zeros and two twos. Now those are two stuff, right? But that could be described because we have two twos, right? And we have one one. But this could also be described because we have a one, right? And we don't have any threes and we don't have any fours, but those can be described because we have two zeros, right? So, so we're already seeing that this can possibly describe itself. So we should try orienting it so that it does, right? So if we have one one and we need it to describe itself, then it has to be in the one position, right? And we have two zeros, so a two has to be in the zero position, and another two has to be in the two position to describe the two twos. And then we had to have zeros describing the three and four. And so this works, right? everything is set up so that it describes itself. Yeah. So actually what you could do is we said that there are no threes and no fours, right? So that means they have to have zeros for them. But we also know that you can't have three or more of any digit, right? So then we solidly know that there have to be two and exactly two zeros in the sequence, right? And then if there are exactly two zeros, well, then you know that there has to be a two in the sequence. And then you're just guessing two numbers, so that should be pretty easy after that. So yeah, this is our sequence, 21200, and that's your answer. 21200. So I was also thinking of another way. Whoops. I was also thinking of another way to do this, but it's not very what do you call it? It like I had a method to do this, but it's not like rigorous at all. I just randomly thought of it and it worked. So what it was that I started with a sequence of five zeros. And then I kept listing out sequences that describe the sequence before it. So to describe this sequence, it would be 50000, right? Because we have five zeros and nothing else. And then to describe this sequence, that's four zeros, and we can't describe it five, right? So then we just have zeros. And then to describe this sequence, we have four zeros and one four. So it's 40001. And then this sequence, we have three zeros, one one, and one four. So then we're at 301001. We have two zeros, two ones, one three, and nothing else. And then this sequence, we have two zeros, one one, two twos, and nothing else. And then this describes itself, so that's your answer. So this was just a random method I came up with. I have no idea if this would work like every time. I don't know. I just wanted to say that. Um, yeah. Anything you want to say there, Bill?
So yeah, for this is kind of a weird problem, I would say, because it's kind of hard to do this in really any like super fast way. There's just a lot of trying and guessing, I guess. Uh, I honestly don't know what to say about this problem. Okay.
Yeah, this one's just kind of weird.
Yeah.
Yeah, we're still on team. We're on four. We just did four. All right. If x is a number such that 3x plus 3x or what 3 to the x plus 3 to the x plus 2 equals 9 to the x plus 9 to the x plus 2, then what is the value of 3 to the x? Express your answer as a common fraction. Yeah. So what should you do with this? Well, what you should do with this is you should factor out a 3x from this, or 3 to the x from this, and a 9 to the x from this. Um, Factoring that out makes everything a lot easier to work with. Because you're like if you factor out 3 to the x from this, then you have 1 plus 3 squared, right? And that's really good because we had two terms of like x here, right? But now we're just getting it to one term and we have a constant term. So that's really good. So we should factor it like that. So if you factor out a 3 to the x, we'll get 1 plus 3 squared. And if we do the same thing with the other side, we'll get 1 plus 9 squared. And then we can just go ahead and get these constants, right? So we have 3 to the x times 10, and it equals 9 to the x times 82. Okay. And then 9 to the x, what we can do with it is we can say it's 3 squared to the x, right? Now, if you have like this, if you have a to the b to the c, this equals a to the b, c, b times c. So this will equal 3 to the 2x. But we can apply this thing backwards as well, right? But we can switch the thingies, right? So like we can say 3 to the 2x will equal 3 to the x squared, right? Now this is good because 3 to the x is like what we're looking for, right? So putting it like that is good. So then we have 3 to the x times 10 equals 3 to the x squared. So like whenever you have like this format, like something to something and that to the power of something, you can just switch the exponents if you want to. And this times 82. Okay, so we can divide by 3 to the x on both sides to get just a 3 to the x here, and then we can divide 82 on both sides, right? So then we have 10 over 82 on this side, and then we just have 3x on this side. And we just want to find the value of 3x. So it's just going to be that, and we want to simplify the fraction. So there's a 2 on both, so we're going to have 5 over 41. And that is your answer. Anything else you want to say there, Bo?
I mean, this is just a simple algebra. There's nothing that really that complicated. Just be careful not to mess up the exponents because, yeah, not to mess up doing the exponents and not have it just like set it up like x plus 2 equals 2x plus 2x plus 4. Don't do that. That's dumb.
Yeah. Yeah, so like you can only add exponents if the terms are multiplying by each other, right?
Yeah.
You can't do anything without adding. All right. Number 6, a standard US dime has a mass of 2.268 grams. A standard US nickel has a mass of 5 grams. Diane has a large bag of dimes and Nick has a large bag of nickels. If both bags of coins have the same total mass, then the total value of Diane's coins is how many times the total value of Nick's coins. Express your answer as a decimal to the nearest 10. All right. So we have a ratio of masses, right? And we're told that they weigh the same, right? So then the ratio of the number of like dimes to nickels is just going to be this mass ratio flipped, right? Because essentially it's like I don't know, mass times your number is some total mass, right? And we're told that this total mass is equal, so it's like constant. So then the mass and the number of stuff that you have of it is inversely proportional, which means that if we have this ratio of mass first, we can flip it to get the ratio of number, right? So then we know the number of dimes over nickels has to equal 5 over 2.268, right? And then we want the ratio of like the value, right? So dimes are twice as valuable as nickels, so we just multiply the 5 by 2. So then the ratio of value is 10 over 2.268. So then what? Uh, then the total value of Diane's coins is how many times the total value of Nick's coins. So Diane had the dimes, so then this is just going to be the ratio, right? Because we had the ratio as dimes over nickels. So like this is describing like the value of them now. But so then you just multiply n to the other side, and then you have then this is just your answer, right? Because then it's d equals that times n, and that's what it says there. So then you just solve that, right? And then you get 4.4. And we want it as a decimal to the nearest tenth, so that's fine. And that's our answer, 4.4. You can also do it in slightly different ways. You know, we can say, I don't know, we can say that there's some uh or yeah, we can assume some like total mass of them and then solve from that. And then we just we cannot care about like the number of dimes and nickels being like decimals. Because I mean that doesn't really do anything to the value, right? Like the ratio of value is still going to be the same, whether it like the number is integers or decimals. Oh, we used to not solve them beforehand, like on the easier problems. Back when we were doing like 1990, like those problems were really easy, even the national ones. But now we look at them beforehand, so we're not destroyed. Yeah. Um, for each positive integer n, a sub n equals 9. Yeah, okay. Uh, a sub n equals 9n plus 2, and b sub n equals 7n plus 3. If the values common to both sequences are written as a sequence, the nth term of that sequence can be expressed as Pn plus q. What is the value of P minus Q? Whoops. All right. So we have two sequences. It's we have positive integer n, and it can be like anything, right? And the n's don't have to be like the same. Like we're not like equaling these two sequences together. Um, because like we're writing both of these sequences out, and then any of them that match up, we put it in our new sequence, right? So that means like these ends are separate, and they can be anything separately, right? So yeah, you could initially just test values and see if anything comes to mind. But so I'm gonna say n1 is for a sub n, and n2 describes b sub n. Um, and these two are both integers, positive integers, and you can be it can be anything, right? All right. So so yeah, one thing we can do is list them out. Sure, we can do that. So this is going to be what? This is going to be 2, 11, 20, 29, 38, and so on. This is going to be 3, 10, 17, 24, 31, and so on. We don't have any initial matches. Um, oh, yeah, okay. Positive integers n, so n equals 0 doesn't work. Um, should we keep listing them out, or I don't know, what do you want to do? Okay, we'll keep going. Oh, and you have calculators, right? You could probably make a function on like your TI to like just list them all out. All right, I listed some out, and we can see we just have the matches 38 here. Oh, okay, yeah. So yeah, yeah. So listing doesn't really get us anywhere, right? Or I mean the stuff is pretty sparse, right? We listed a lot of stuff out and we didn't really see anything. We just got one match. So one thing we can notice is that A sub n is always going to be 2 mod 9, right? Because 9 times n is always going to be 0 mod 9 and 2 is 2 mod 9. And so just like that, B sub n is also going to be 3 mod 7. So now what? So so if we basically our sequence thing is going to be repeating by uh wait, am I dumb? Okay. Oh, okay. So whatever a sub n you have, you can okay, so a sub n describes all the integers that are 2 mod 9, right? And b sub n describes all the integers that are 3 mod 7, right? So if you have these and you add both of them by 63, which is 9 times 7, they're both still going to be in their own sequences, right? Because like if you add 63 to this, you're adding 0 mod 9, right? So it's still 2 mod 9, so it's still going to be in the sequence A sub n. And same thing with the B sub n, right? So and that's the least common multiple of 9 and 7, right? So then you know your sequence has to be like your new sequence, its numbers has to be 63 apart, right? Which means that P has to be equal to 63, right? And then we can just use our initial value of 38 to find what Q is, right? So 38 is our first one, right? So then we just do 63 minus 38. So then we have to have a minus 25 here, right? So then this has to be our sequence, right? So then P minus Q is just 63 minus negative 25, or 63 plus 25, which is 88. And this is our answer, 88. So we also did it in a different way when we worked it out beforehand. What was it? Phil, do you remember?
Uh, then we just look at the period and be like, oh, 7, 9, 63.
No, I think that was your method, but I thought of a different thing, right?
Oh, I don't quite remember, honestly.
Uh, there was a different way. Um, what was it? Maybe it was equaling these two things together. Oh, maybe it was. I think
It could be.
it was like so we equaled these two things together. So this is A sub n, this is B sub n. So when this is satisfied, where n1 and n2 are positive integers, then then like one of these values will be in our sequence, right? So, um, so we can do it like this, and then what? Uh, and then I think it was this. 7 times n2 has to be congruent to 8 mod 9, right? Because this is 0 mod 9, so this has to be 8 mod 9 for this to be 1 mod 9. So like you're just taking this mod 9. And then what? And then oh, okay. And then you can notice that if you add n2 by 9, it's not going to change anything, right? Because 9 is 0 mod 9, right? Which means that n2 is going to be repeating in periods of 9, right? Or like n2 values that work, right? Uh, which means what? Which means uh then we have like a sequence of n2s that work, and it's gonna be 9 times n2 something, right? Um, and if we just test if we just test like some initial values of that, then we should be able to get the constant value. So if we have 7 n2 is congruent to 8 mod 9, then what? Then okay, then we see the first value that works is 35. So then n2 equals 5. So then this is just n9 times n2 minus 4. So we know that this sequence describes the n2s that work. Oh, this should be like n sub 3 or something else, right? So this would describe the sequence of n2s that work, right? So n2 being 1 would be our first n2 that works, and n3 equaling 2 would be our second n2 that works, right? So then what? Then we can plug this into our b sub n formula here, and then we'll get b sub n in in a sequence of n sub 3, but n sub 3 is just positive integers, right? So then okay, so if we do that, what? If we do that, then we have 63 n sub 3 minus 28 plus 3. So this b sub n sequence is just going to be our new sequence, right? Because our new sequence is the value of the common of the common value. So we can just like take, like b sub n is going to be that value, right? So that means b sub n is just going to be our new sequence if we have it in terms of n sub 3, which we said it was just a positive integer sequence describing n sub 2, right? Okay, so then what? Then look at this. Then we have 63 times n sub 3 minus 25, which is the exact same thing that we had before, right? So yeah, so then you have p and q again, and you get the same thing. All right. Yeah, it's usually best just to go with the first thing that you think of. You usually don't want to think too long about like about like the methods that you're going to use. I mean, but I don't know. You might want to put some time into that, but not forever. So anything you want to add on to that, Bill? So this
Um,
was the first thing I thought of. The first thing that we did was Bill's method, I think.
well, yeah, my method is more of just, you just look at the problem and you're like, that has a period of 9 and that has a period of 7. So the period is gonna be, the least com the least common multiple, which is 63. And then you have a period of 63. Now you find like the first number that works, and then you've used that to find whatever you've used that to find q.
Yeah, okay. Um, both methods are fine, but Bill's is faster. Yeah. All right. So let's move on now. We have number 8, quadrilateral APBQ shown here has vertices A 0, 0 and B 8, 0, and vertices P and Q lie on the line given by the equation 4x plus 3y equals 19. If PQ equals 3 units, what is the area of the quadrilateral APBQ? Express your answer as a common fraction. All right. So yeah, we want to find the area of that quadrilateral. Well, this quadrilateral is just two triangles, right? So we find the area of the two triangles, then we're all good. And finding the areas of the two triangles is actually pretty easy, right? Because we're given the length of PQ, right? Which we can set as the base of the triangle. So then we just need to find the height of the triangle, which would be this point to, and which would be the length of the segment of this point perpendicular to this line, right? Which is easy to do because we have the equation of this line and we have like the coordinate of this point, right? And we could do it to this one as well. So that's pretty easy, right? So we can first look at APQ. So its base is 3, right? Um, and then we want to find the height. My drawing is pretty bad, but it's like here, right? I don't know. We want to find the height. Um, so so it's going to be a line that is perpendicular. It's going to be a line that is perpendicular to this line, right? Because it has to make a right angle with this line, and it has to go through 0, 0. So if it's perpendicular to this line, what does it mean? It has the negative reciprocal slope of this line, right? And what's the slope of this line? Well, it's just negative 4/3. Okay, so the slope of our new line has to be the negative reciprocal of this, right? So it has to be slope of 3/4, and we know that it has to go through the point 0, 0, right? So then what? Then you just use point slope, or I mean, you just know that it has to be y equals 3/4 x, right? Because it has to cross through 0, 0. All right. So now we know the equation of this line, right? So we can find where this point is, like its coordinates, if we find the intersection of this line and this line, right? So then we have 4x plus 9/4 x equals 19. So then it's like then it's 25/4 x equals 19, or x equals, oh, that's not pretty. Uh, that's what? That's 76 over 25. I think this is right. I don't think I messed up anywhere. All right, so we know Q as at the point x equals 76 over 25, and that means its y is going to be 3 times 76 over 4 times 25. And I'll just leave it at that for now. Or you can simplify a little bit. So, this goes into 4 actually. So, this is 19. So y is 3 times 19 over 25, which is just 57 over 25. All right. So this is the coordinates of the point Q, right? So then now we can find the, oh, I no, not Q. I'm sorry. So so uh, this is the point. This is the coordinates of the point where we have our perpendicular line to, right? So I don't know. Let's just call this S. So this is the coordinates of our point S. So if we have the coordinates of this point, now we can find the length of this segment, right? Which is what we wanted, because this is the height of our triangle, right? And we already have the base. So the length of this is
Hey
just going to
Austin.
be,
Hey Austin.
oh yeah,
1001 is asking, can he can he find the area by finding the area of a big triangle and subtracting it by a small triangle?
uh
I would say no because you don't know like it's not given.
you don't yeah, P and Q can be like
Yeah, they
anywhere.
can be anywhere. So it's
So
not
you
really
don't
feasible.
really know yeah.
Yeah.
It's better to work with the given that PQ is 3 units.
Yes.
And am I doing this right? Are the numbers this bad? 76 over 25?
Uh
I don't know. Well, we have calculators on team, so whatever. Yeah, yeah. Okay, so the length of the A to S is going to be, um, is just going to be, like, 57. Okay, I'll just write it out. 57 minus 0 squared plus 76 over 25 minus 0 squared, square rooted, right? So let me just find that. Oh, we want it as a common fraction. Okay. So if you do it on the TI, you can get it in fraction form. Okay. Oh, this is pretty nice actually. So this comes out to 19 over 5. All right. Um, so then the area of our first triangle is going to be 3 times 19 over 5 over 2, right? Times 1/2. And this is just 57 over 10. Okay. And then now we need to find the length of that segment and find the area of or it's going to be like here. We need to find the length of this segment so that we can find the area of this triangle. So what's that going to be? Oh, okay. Well, we have to find a new point, right? This was just for a. So we have to find a new line. It's going to still have slope 3/4, so it can be perpendicular to this line, but it's going to cross through a comma 0. So then we just use point slope. So y equals 3/4 times x minus 8, which means that y equals 3/4 x minus 6. Okay. And then again, we find the intersection of the two lines to find where the point is. So this is going to be 9/4 x minus 18, and a equals 19. All right, and you can just put this into your TI and we'll solve it. Whoops. Okay, and then we get x equals 148 over 25. Okay, and then y is going to be, well, actually, it would be better just to put these two into a system of equations, and then just find the values of x and y. Yeah, TI is really powerful. You can do a lot. Um, all right, so if we plug in x, we will get y equals negative 39 over 25, which makes sense because it looks like y is going to be negative, right? So then, what's our area going to be? Or what's our height going to be? It's going to be negative 39 over 25. Okay, sure. Minus 0 squared plus 148 over 25 minus 8 squared. And you can flip these if you wanted to, but it doesn't matter because we're squaring it, right? So the signs doesn't matter. All right, now we should put this into our TI. So what do we got? Uh, okay, then we get that this is equal to 13/5. So not bad. So then the area of that triangle is going to be 1/2 of 13/5 times 3, which is just 39/10. Okay, finally. Now we got that the area of the first triangle was 57/10 and our second triangle was 39/10, which means that our total area of the quadrilateral is 96/10. And we can simplify that to just 48/5. So that should be our answer. The numbers are quite bad on this actually. So yeah, you should definitely try to solve like those system of equations by plugging them into your calculator, not by actually solving them. Um, I think I don't know. I think this is not too bad. It's just like the numbers are pretty bad. I don't know.
So, while you were talking, I thought of a better method.
Oh, cool.
So, it doesn't look, go back to the problem, go back, okay. It doesn't say where P and Q have to be, so you can have Q on the x-axis, right?
Oh, wow.
And then using that, you can find the y value of P because if
Oh,
PQ is 3,
that's actually really good.
yeah, if PQ is 3 and the slope is what's the slope? 4/3, you know, it's really easy to find where the y value of P is.
Yeah, yeah.
Okay.
So, okay, so there's literally nothing specifying where P and Q is, right? Like, like literally nothing. So you can just have a Q on the x-axis, like Bill said, and then just solving it there. We should try that and see if it's a lot easier. So, okay, so if Q is on the x-axis, and we have this line, so P is going to be here, and we know that this length is 3, right? All right, so if we just find the coordinates of P, then we can find the height of this, and we already know that the base of this is 8, so then we just find it, right? So then, uh, we know that this is 3, right? So using the slope of that, um, so the slope of that is what? Negative 4/3. Um, which means that which means that this length has to be uh four. It has to be 4/3 times 1/3. So it has to be 4/9. I think so. No, it has to be 9/4. Is that correct? Because like we have a slope of 4/3, right? So then it's gonna go. Oh wait, well this is the actually I'm dumb.
You
This
are.
is the on the line, not like the
Yeah.
y.
Yeah, on the line.
So that's totally wrong. So so we can just say like this is x and this is or no, okay. We can say this is so messy here. Okay, if we say that this is x, because we have a slope of 4/3, this has to be 4/3 x.
Yep.
And we know that this is 3. Now we can use the Pythagorean theorem.
And it's a 3-4-5 triangle.
Oh, really?
There's 3 and 4. What do
What?
you think the third side is?
Oh, okay. Or you can just plug it out onto your TI.
Oh man, Austin really ought to search up with 3 and 4.
What?
Square root of 3 squared plus 4 squared. What is that?
Wait, what?
Never mind, just go. Yeah, just do it. Yeah, it's fine. It's fine. It's fine.
Okay. 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 Okay, then you get x equals 9/5. Okay, if x is 9/5, then this is just 36/15, right? We get a base of 8, so then the area of this is just 4 times 36 over 15. Oh no, 36 that's 3 actually. So then it's 12 times 4 over 5. And then okay, that is our answer. It's 48/5. Yeah, that
Yeah.
way is a lot faster. That's actually really good. Cool. Um, yeah, anything else you want to say?
So yeah, on problems like these, when you see that, there's a factor that it doesn't care what you set it to us, you should see if you can like set it so that there's an easier place to use, easier place, like a place where it makes the numbers easier to do, I guess.
Sure. Yes. I mean, I don't know. If I like if I was solving this problem, I would just go for that initial solution. Um, but if you want to, you can spend some time to see if there's anything like you can assume to make it easier. All right, let's move on. 8 blue and 5 orange tiles are arranged in an ordered line such that the tile on the left must be blue and every tile must be adjacent to at least one tile of the same color. For example, if an arrangement of 4 tiles was made, the only possibilities would be those. How many arrangements are possible if all 13 tiles must be used? All right, so we have 8 blue and 5 orange tiles, and like the tiles uh have to be um has to be adjacent to at least another tile of the same color. And we have to start with blue on the left. So that means blue has to be our second tile as well, right? Because this blue has to be touching another blue, so this has to be blue. But after this we can have orange or blue, right? Because this blue is already satisfied. All right. So what should we do? So we can just try some things out, right? Um, and then see if we can find anything about the sequence. So, try to putting a blue here, that's fine. I can put any number of blues here, really. And then let's say I put an orange. If I put an orange, my next tile must be orange, right? Because this orange has to be surrounded by orange. Now the next tile can be orange or blue. Let me just put it as blue. And then I can put as many blues as I want, right? And then I can put another orange if I wanted to. And this orange would have to be with another orange. Now, what if I put a blue here? Well, I have 5 oranges, right? So I used 4 oranges and now I have 1 orange. But now the last one orange has no other orange to pair with, right? Everything has to come in like pairs or more than pairs, right? So like everything has to be like 2 or more than 2, right? So then this orange would be by itself and there's no way it can be by itself, right? So that means it had to have been with this with these two initially, right? And then you just have blues. All right, so what is this telling us? Well, this is telling us that if we think of like replacing oranges in a sequence of blues, our oranges can only come in 2 oranges and 3 oranges, or 3 oranges and 2 oranges, or all 5 oranges together, right? And there's no other way you can do it because oranges can't be by themselves. All right. So now we can separate it into cases. We can separate it into our 5 O's case where all our oranges are together, and we can do our 3 and 2 O's case. So our 5 O's case, how many sequences are there going to be? So, well, we know that we have to start with blue, and then we can put our 5 oranges anywhere, right? So we can put it in the third spot, or okay, we have 13 tiles, right? So, or we can go all the way to the 9th spot, right? If we put it in the 9th spot, the last orange will be at the very end of the sequence. So this seems like the number of 5 O's you can have is just 9 minus 3 plus 1 is what? Is 7, right? But it's actually not. Because if you have the 5 O's starting at 8, then you have 5 O's and you have a B at the very end. But what? You can't have a lone B, right? You can't have a lone anything. So if you have 5 O's at starting at position 8, this actually doesn't work. So you actually have to subtract 1 from this, and your total number of 5 O's is actually 6, not 7. So that's the thing to be careful of. That can totally trip you up. All right. Now what about 3 and 2 O's? Well, we can think of like our 3 O's being here and our 2 O's being here. And then we're inserting B's into the spaces in between. So we're inserting B's into here. And then we can think of how many ways can we insert B's into here, right? Well, we know that we have to start with 2 B's always. And then we can think of we're inserting B's everywhere, right? Well, we know that we have to have B's in the middle, right? If we did not have B's in the middle, the O's would be together and they would make 5 O's. And then that's just our 5 O's case. And we don't want to count things twice, right? So you have to have at least 1 B in here to separate these 2 O's, right? That is so off. We have to have at least 1 B in here, right? Well, a B can't be by itself, right? So this B has to come with another B. So there has to be at least 2 B's in the middle here, right? And so that's already decided for us. That's not going to come in to like our counting, right? So now how many B's are we left with? Well, we had 8 B's at the beginning and we've used 4 already. So now we just have to sort 4 B's into these 3 circles. And yeah. So now I don't know. You can do this in a number of ways. It's not too hard. We can just look at cases of how many B's are in the last spot. So we can think of 0 B's in the last spot, 2 B's in the last spot. We can't have 1 B in the last spot because then it's by itself, right? 3 B's in the last spot or 4 B's in the last spot. All right. So if you have 4 B's in the last spot, well, that's just one, right? That's just one way you can do it because you just use all your B's, right? Now, what if you have 3 B's? Well, you have 3 B's in there. You can have a B in here or a B in here, and those two are different, so that's 2 cases. Now, what if you have 2 B's in there? Well, you have 2 B's to distribute to these 2. Now, be careful in that it's not
Be careful.
too. Wow.
I'm sorry. Okay.
Be careful. Okay. So be careful that the number of ways to do 2 B's is not just 2 squared, right? Where you're choosing like um like 2 things for each B, because you're not really doing that, right? Because then you're counting like if you put a B into here and then a B into here, or a B into here and then a B into here, you're counting those as separate cases, but they're not, right? So you can't just do that. Um, what you could do is just like think of it. You can have like two B's in here, two B's in here, or a B and B there. So then that's just three. Or you can I don't know. That's pretty easy. Whatever. Okay, so what if you have zero B's in here? Well, then you have four B's to go into each of here. So okay, so a better way to think of it is it's just like how many B's are in like I don't know, the first circle, right? Um like let's say in a zero blue case in here. Well, you can have either 0, 1, 2, 3, or 4, right? Because we have four blues to distribute, and we can have 0 or 1 because we had blues starting here, right? So we can have a lone B in here because it has a B there. All right. So this first spot can just have any number of these blues, right? And those are all distinct, and that's a valid way to describe this, right? So then the number of cases with our zero blue case is 5, right? This is 0 through 4. So now we can just add these together, and this is just 11. All right. So now we have our number of T cases. So then it's just 17. Oh, did we check our answer to that? Oh no, yeah, we did. Oh crap. Oh, I missed something crucial actually. Um, so this is a very easy mistake to make. I probably should have made note of it
Again,
somewhere. Yeah,
good
we did
job.
this in our working thing before
We
actually.
did.
So in our 3 and 2 O's case, you have to multiply whatever you get by 2, right? Why? Because so we said we had our O's here, right? And I initially said we had 3 O's here and 2 O's here. But we had to account for the flipping of this, right? We can have 2 O's here and 3 O's there. And that wouldn't change anything, but it's distinct, right? So we have to multiply this by 2. Wow, I can't believe I made that same mistake. Okay, so whenever you have this, you like whenever you set it up first, you probably want to make a note like multiply 2 at and just like underline it so you don't forget. Um, yeah, okay. So we have to multiply this by 2, then we have 22 plus 6, then we get 28. And that is our answer, 28. All right, anything you want to say there, Bill?
Other than like, just be careful that you counted every single one of them. Um, the counting itself isn't all that complicated. Just be careful that you counted all of them.
Yeah, be careful of these mistakes, like the multiply by 2.
Yes,
Um,
like
and this one was I don't know. I feel like this one is kind of brutal in missing that you can have one blue at the end.
yeah,
Yeah. Um, yeah. Me and Bill are both in high school. We're in 10th grade, both of us. We did not do math counts in middle school. Our school didn't have it.
we did not know
So
it existed in
yeah,
middle
we,
school.
we we didn't know it existed either. I feel like that was so bad. Like no one really told us about math counts or like AMC or whatever. And we just found out like I don't know, like a bit into freshman year. Yeah. And we actually we started in math counts at our middle school. So that was kind of our inspiration for doing math counts at our middle school because like we didn't have it. Or yeah. All right. So now let's move on to number 10, our last question for team. Spring City is replanting the grass around a circular fountain in the center of the city. The fountain's diameter is 10 feet, and the grass extends out from the edge of the fountain 20 feet in every direction. Grass seed is sold in bags that will cover 300 feet squared of grass. How many whole bags of grass seed will the city need to purchase? Okay, so what is this? We have a fountain in the middle. It's a diameter of 10 feet. And we're told that grass is everywhere else, extending 20 feet in every direction. It's like 20 feet there, 20 feet there, right? So what does that make? Well, then that's just another circle of grass, right? And then this bigger circle has a radius of 15 feet, right? All right. And then all of this is grass and this is fountain, right? And I don't know. Uh, um, we grass seed is sold in bags that will cover 300 feet squared of grass. So we want to find the area of the grass, right? And that's really easy, right? We just do a what? 15 is 25 feet. Yeah, I know, it's really easy. Much easier than the last one. Um, all right, so this one is just 25 feet squared minus 5 feet squared. That's the area of our grass. And we just find what this is. We can even use our TI, but this is so easy, right? And that's 600 feet squared. If I did everything correctly.
You forgot
Did I
the
do everything
pie.
correct?
You forgot the pie.
Oh my God, I forgot the pi.
You did it. You did it again.
I did I do this in
You
our
did
thing?
this when we were going over this.
Wow.
You did it
Wow. I
again.
think circles are squares, guys.
Okay.
I think circles are squares.
Absolute beautiful.
Okay, well, if you have 600 pi feet squared, that's even a really nice number to do this, right? Then it's just 2 times pi bags of grass. So then you have like 6.28 stuff, right? But you need how many whole bags? So then this rounds up to 7. That's a really easy problem. Well, let's look at that. 7. Very cool. All right, anything you want to say to that? Bill.
Don't be like Austin, and yeah, that's pretty much it. This is a really easy problem. So
Yeah. All right. Now let's move on to 2016 Nationals. All right. Okay. Now these are the spicy problems. Very spicy. Okay. All right. All right. We spent like 4 hours going all
we
of
spent
these.
4 hours going over this test. So yeah,
Yeah, but I mean, it shouldn't really have taken us like 4 hours.
yeah,
Because my mic was being bad and
yeah.
I was like
We were
switching
having
computers a lot.
we were having mic problems with Austin, so we couldn't really. We were having trouble doing the problem.
Yeah, but it did take us a really long time. All right, all right. Okay. What is the result when 1/3 of 1/2 of 1/5 is divided by 1/6? Expressed here, it says convex. Okay, we've got to start easy, right? It's just it's preparing you for the problems at the end. So right, this is pretty easy, right? You're dividing by 1/6, so you're multiplying by its reciprocal, so it's just times 6. Well, you have over 3 over 2, so that cancels. So then it's just 1/5. That is your answer. Karthik is making a pattern that consists of 3 vertical stripes. He has a selection of stripes that are red, blue, green, and white. If no 2 adjacent stripes can be the same color, how many different patterns can Karthik make? The red patterns red, blue, green, and green, blue, red are considered different. All right, we have 3 stripes, and he can choose out of 4 colors, and we can't have 2 adjacent same color stripes. All right, so let's just choose some initial color. Let's make it red. Or actually, a better way to do this is just to do a total generalization instead of doing like more or less like caseware kind of stuff. So a total generalization would be saying we can choose any color for our first color, right? So that's 4. We have 4 colors, right? But our next color cannot be the same as our first color, right? And it can be any other color, right? So then that's 3 possibilities. Now the last color just can't be the same as this color. And that's just saying that we have 3 to choose in our last color, right? So then it says 4 times 3 times 3, not bad, 36. All right. Miss Parker has 3 types of inhabitants on her farm. humans, horses, and spiders. The humans and horses are both mammals, but humans have 2 legs each while each horse has 4 legs. The spiders each have 8 legs and are not mammals. If the number of human legs, horse legs, and spider legs are all equal, what is the ratio of mammal inhabitants to the total number of inhabitants, especially in such a common fraction? Alright, so we can just assume like the number that of legs that are equal is like 8, right? That's like the least common multiple of all of these. So then we have 4 humans, 2 horses, and 1 spider. And we want to find the ratio of mammals to total number of people or inhabitants. So then that would just be 6 over 7. So 6/7. Which is the answer. So again, you can assume the total number of legs because it doesn't specify, right? Yeah, and like whatever you have it as, it will have the same ratio. All right, Joanna forms an arithmetic expression using each of 1/10, 3 1/2, and 2 4/5 exactly once, and using each of the operators, or 2 of the operators, plus and divide exactly once, with as many sets of parentheses as she wishes. What is the absolute difference between the greatest and least possible values of Joanna's expression, especially since it's a mixed number? Okay, so we want to find the greatest and least possible values of Joanna's expression if we do that stuff. And what is that stuff saying? Well, it's saying we have to use plus and divide exactly once, but we can orient the numbers in any way. So all right, so to maximize it, we're gonna want to divide by 1/10, right? You want to divide by the smallest value so that it multiplies by the biggest value, right? And we want to add these 2 values together because it's in the numerator and we want it to be as big as possible. So this has to be our greatest possible value of the expression, which is just 6 and what? So this is 5/10, so this is 8/10, so then this has to be 3/10. And we're multiplying by 10, right? So then our greatest value is 60 plus 3, which is 63. Okay, well, what is our least possible value? Well, we want to divide by the biggest thing that we can, and we want to have our numerator as the smallest thing as we can, right? So then it would be like this. So then what would we have? We would have 1/10 times, we found it before, right? 6 3/10. So then this is 1 over 63. Very cool. The reciprocal of that one. Okay. Now we have 63 minus 1 over 63, which is just 62, and 62/63. That's your answer. Okay. Olar runs 1 lap around Carpenter Park in 6 minutes, sorry. Nori runs 1 lap around Carpenter Park in 8 minutes. If Olar and Nori start together and run in the same direction around the park, how many laps will Olar have completed the first time he and Nori are together at the starting point? Okay, the first time Olar and Nori are together at the starting point will just be the least common multiple of their lap times, right? Which is just 24 minutes. So they will be together back at the start in 24 minutes. That should be pretty easy to think of. All right. So if it takes 24 minutes, how many laps will Ola have completed? Well, it's just 24 over 6, which is just 4 minutes. What? I'm sorry, 4 laps. That's our answer. Yep, that's your answer. All right. The flag of the United States showed here has a blue rectangle containing 50 white stars. Horizontal length of the canton, which is this blue box here, is 2/5 of the horizontal length of the flag. And if you didn't know what a canton was, it should be pretty easy to figure out, right? Because it says, like there's only really 2 things you can talk about, right? Like the box or like the not box, and you can really only say that the box is like that, right? Okay. The remainder of the flag consists of 13 alternating red and white stripes, all of equal width. Seven of the stripes are seven of the stripes are to the right of the canton. What fraction of the area of the flag is red? Express your answer with a common fraction. All right, so we can first look at this bottom part where it's just white and red stripes. So we know that this part of the total, the area of this bottom box of the total flag is going to be 6/13 because we have 13 stripes all here and we have 6 stripes here, right? So like the length of this part is like 6 units while the length of the entire part is 13 units. So the area of this box with respect to the whole flag is 6/13, right? Okay, and then we had to multiply this by 1/2 to get the to find the red area, right? Half of this area is red. All right. Now the area of this top box is going to be 7/13, right? And well, we want to multiply this by 1 minus 2/5, right? Because then it will just get us the area of this box right here. Because we know that this length is 2/5, so the area of this with respect to that is 1 minus 2/5 or 3/5, right? All right. And then we just need to find the ratio of red to white in this box here, which is just 4/7. All right. What do you have here? It's 3/5 times 7/13 times 4/7. Sevenths cancel. We have 12/65, and there we have 6 26ths, right? Oh, you can simplify. You can have 3/13. Okay. And then we need to add these together. So then it would be 12 plus 15 65ths. That's 27 65ths. And there's no way to simplify that. So that has to be your answer. There it is. Oh, and am I going too fast? I was trying to go as fast as I can because I thought these problems were pretty easy, but I don't know. Okay, I'll keep going at this pace until my voice dies. All right, Graham is training to compete in the 1 mile race for his track team. His time in minutes on practice day N, where N is a positive integer, is given by the formula T equals 8 over 1 plus all that. Okay. For what value of N will Graham's time to the 1 mile race first be less than 6 minutes? All right. Well, this time just describes that, right? So you just set them equal to each other, and then you find what N is. And N is, well, it just asks for what value of N. So, that should be pretty easy. So then you just do some stuff. Or actually, yeah, you should probably put inequalities. But or you can do equality and then just think about it a little bit. It doesn't really matter. All right, so 0. Oh, whoops, this should be 0.005. Okay, that should be just 1 over 200, right? So 6 times that is just going to be 3 over 100. So plus 3/100ths of n. 2 equals 3/100ths of n. So n has to equal 200 thirds. All right, now we think about the inequality. So n will have to be like the ceiling of this, right? Which is what, 201 over 3? Which is what, 67. That's your answer. Yep, that's your answer. All right, if a minus 1 over a squared equals 4, what is the absolute value of a cubed minus 1 over a cubed? All right, so so what we want to do, so okay, so we want to find the value of 1 minus 1 over a in this problem, because if we cube 1 minus 1 over a, we can get an expression that is close to this, and then we can work with it. So a minus 1 over a either equals 2 or negative 2. Okay, so that means a minus 1 over a cubed is going to equal 8 or negative 8. And we also want to expand this so that we get like that, right? So then we have a cubed minus 1 over a cubed. And then we have minus 2, or it's not 2, 3a, and then plus 3 3 times 1 over 8, right? Because so like how you do that is just like the binomial theorem, right? You have this squared times this times 3, which is that, and then this squared times that times 3, which is that. Yeah, if you guys don't know the binomial theorem, you can just let me know and I can do that. All right. So then this is actually really good because you can factor out the 3, or actually negative 3, and then you will get 1 minus 1 over a, which is good because that is what we found earlier, right? So and we know this equals a comma negative 8, right? And we want to find the absolute value of this. Well, what we can do is we can just I don't know, we can just assume any of these values. So we can assume 8. And in our 8 case, that means a minus 1 over a is 2. Okay, then what? Then this just equals 6 plus 8, which equals 14. And if we did it the other way, where this was negative 8, then this would be negative 2, and then this would just be 6, or what? This would be negative 8 minus 6, which would be equal to negative 14, which has the same absolute value. So yeah, the absolute value is 14 either way, which is our answer. 14, yeah. So yeah, this kind of thing is kind of well known, especially in like AMC, AME kind of stuff. It's just like the x minus 1 over x, or x plus 1 over x, like you just do stuff like that. Like you want to like square it or cube it to get like expressions that have these. All right, let's move on. Do you have anything to say of anything that we've done yet, Bill?
Um, well, all the last ones, like, they didn't really have any, like, super complicated stuff, I'll say. It's just that, there's just that one thing. Right, for the last problem, like, you'll see something like that a lot, where you have to
Um,
convert stuff into that form, I guess.
yeah, yeah. All right. Um, Matt left home traveling towards the mountains to go camping. His brother Mark started along the same route 2.1 hours later, traveling at a rate 35 miles per hour faster, trying to catch up to Matt. What was Matt's average speed if it took Mark 1.2 hours to catch up to him? All right, so we have Matt somewhere here, and then Mark somewhere here. And then Mark is traveling 35 miles per hour faster, trying to catch up to Matt. So what is it saying? Well, it's saying that they had some initial distance, right, between each other, and then this and this distance is being covered by a rate of 35 miles per hour. Like, yeah, and it took what, 1.2 hours trying to catch up to him. Whoops. So then this distance, the total distance is just going to be 35 miles per hour times 12. And this distance is just our initial distance that they were apart, right? And so that will be useful. Okay. Oh, 1.2, yeah. And this is just what? This is just 35 plus 7, which is just 42. Okay, so the initial distance that they were separated or when Mark started is 42 miles, right? So that means Matt went 42 miles in 2.1 hours, right? Because that keep left off there, and Mark came at 2.1 hours later, right? Okay, so that means Matt's average speed is 42 over 2.1, or 42 miles over 2.1 hours. All right, so what's that? You can get a 7 out of both of them. So then you have 6 over 0.3. So then it's just what? 6 over 3/10, which is just 20. So Matt's average speed is 20 miles per hour, which is the answer. All right. For what digit A do the 3-digit numbers A43 and A79 have a product of 43A597? All right. So we should look. Well, we should be like kind of testing A's. We look at we look at like their upper range and their lower range of their product. So what happens if A is 1, right? Well, the lower range of the product is going to be 100 squared, right? Because this is if we had A equal to 1, then this product is clearly more than 100 squared. So that's the lower bound, right? So this is just 10000. Okay, but that doesn't tell us anything, right? And the upper bound is 200 squared, right? And this is 400000, right? And this is wait, no, this is 40000, so 40,000, which is much less than that, right? And if this is upper bound, then that means A can't equal 1. And this is much less than that, right? This is like more than 10 times less. So we should try something bigger. Let's try A equals A. The upper bound is going to be 900 squared, right? Which is 881,000, which is 810,000, which doesn't tell us anything, right? This is bigger than that. Okay, what's its lower bound? Well, it's 800 squared, so it's going to be 640,000, which is more than that. So which means A can't be 8 or greater, right? Because its lower bound is bigger than that. All right, so what if we try A equals 6? Well, A equals 6, its upper bound is going to be 700 squared, which is 490,000. Okay, and that doesn't tell us anything. And its lower bound is 600 squared, which is 360,000. And we see that this number is between this, so then A has to equal 6, right? The other numbers would not be in this bound. So like A equals 5, this would be its upper bound. And A equals 7, this would be its lower bound. So then it doesn't encompass that number at all. So it has to be A equals 6. So that's our answer, A equals 6. All right. If A equals B minus 1 equals C minus 3, and that for some integer A, what is the value of the sum A plus B plus C? Okay, so the most systematic way to solve this is just to say B equals A plus 1 and C equals A plus 3, and then put it into there and just solving it. And we can see if that works. It might not work, but we'll just see. So 1 over A plus 2 over A plus 1 plus 1 over A plus 3 equals 1. Okay, and we want to solve this for A. And then we will get B plus C, or B, and C as well. Okay, so what should we do with this? Well, we should put this all into one big fraction, right? So the denominator is going to be A times A plus 1 times A plus 3. And the numerator is going to be A plus 1 times A plus 3 or plus 2 times A plus 3 plus A times A plus 1. And this is equal to 1. And we need to expand all this. And we can leave this, and we should expand the top. So then the top is A squared plus 4A plus 3 plus 2A squared plus 6A plus A squared plus A. And we'll just leave the bottom as is. I'm not going to write it, and A equals 1. Or actually, we should put it over there, right? Okay. And then we should simplify this, and we should also expand this, so then we can like combine terms, right? So we have a squared, a squared, a squared. That's 4a squared. We have 4a, 6a, a. That is 11a. And we have just 3. So that's just 3. All right. And the 1, we move this over there. And now we just expand that, right? That's a squared plus 4a squared. No, a cubed plus 4a squared plus 3a. All right. Now let's just solve this. This is just the cubic. Not too bad, right? The 4a squares cancel. 3a minus 11a is 8a. And then we have the minus 3. All right, we have a cubed minus a minus 3 equals 0. Okay, now this is more or less um the moment of truth. If we have like 2 or more solutions of a here being some integer, then we're kind of screwed um because then it can be either of those. But if there's only one, then it's very good because then that has to be our solution, right? So so um so let's just think of it a bit. So we can find roots by plugging stuff into A and seeing if it equals 0. Well, 0 obviously doesn't work. 1 doesn't work either. 2 is 8 minus 16 minus 3, which does not work. Well, what's 3 though? 3 is 27 minus 24 minus 3, which does equal 0, which means a minus 3 has to be a root, or 3 has to be a root. So we can factor into a minus 3. So now we should use the, what is it called? What is this called? I forgot. Synthetic division. Yeah, you
Yeah,
just use
okay.
synthetic division.
Synthetic division.
And to find the, if you factor out a minus, it's a quick way to find what this polynomial divided by a minus 3 is. Okay, so then this is just like that. So when we factor it, it has to be a squared plus 3a plus 1. So these numbers correspond to those coefficients. And if you guys don't know how synthetic division works, is these are the coefficients of the polynomial you're dividing by. This is the root, and like basically you have to be dividing by like x plus c. You can't have any coefficient on x, and it can't be it has to have a degree of 1 and stuff. So then you put the root into here, and then what you do is you first bring this down. That's the coefficient of the starting thing, and then you multiply this by this root, and then you bring this down, or you add these and bring it down, and then you multiply, and then you add those and you multiply, and so on. And then these are the coefficients of your new polynomial. And this thing always has to be 0. This is actually a root, right? All right. So that means that this, if we factor the a minus 3 out of this, then we have to have a squared plus 3a plus 1. Now look at this. This has to have this has to have no real roots, right? Because if we well we can think of the wait, actually no, it does have real roots, but they are not integers. If we use the quadratic equation, we have 9 minus 4 rooted, right, which is 5 rooted. So that's not going to be an integer, and we have to have an integer, right? So that means a equals 3 is our only solution that we get out of this, which is very good because it tells us that a must equal 3. And so that means what? B equals 4 and C equals 6. So then their sum is 13. That was kind of long. Um, anything you want to say to this, Bill? Like, do you think there's a better way to do it instead of I mean, like
I mean,
the way we did it, yeah, yeah.
that is like the most straightforward way, I would say. Like the most
I mean, but
simplest way. Yeah.
what if we had 3 solutions to a cubic? Or
Okay.
wait,
Uh,
would that even be possible?
I if there was three solutions to our topic, then there would be like three possible answers, and I don't think we can do
Yeah,
that.
yeah. So that's actually fine doing it like that. Yeah, if there were three solutions, then all of them do like have to be valid anyway. So then then yeah, or you can just use any one of them to find the sum. All right, the answer is 13. Three distinct vertices of a regular hexagon are chosen at random, and a triangle is formed by joining the three vertices. What is the probability that the triangle formed is a right triangle? Express your answer as a common fraction. All right, so we have a regular hexagon. Whoa, we actually have the shape tool. See, this is really good. Just have a regular hexagon now. All right, so we choose any three vertices, and we want to find the probability that it's a right triangle. All right, so what we should do is we should find the number of right triangles that can like be on this hexagon, and then we divide that number by the total number of triangles that can be formed, which is not too bad to figure out. So let's just choose any point like this point without loss of generality. And then what points can we use to make a right triangle? Well, if we use this point, we're gonna have two right triangles. One of them is just going to here, and another of them so that's right triangle, and another would be going to here. So then this is the right angle. And the others don't work, right? Because then it's not a right triangle. Okay, so what if we choose this point? Well, we have two right triangles again, because if we go there, then we have a right triangle there, and we're also going to have an opposite one right there. Or wait, what? No. If we have this point, we're also going to have like this. So that's the second right triangle. And the other points don't work, right? This point is not a right triangle, and this point is not a right triangle. It's an equilateral triangle. All right. So this point had two right triangles. This point had two right triangles. Now what happens in this point? Well, we still have two right triangles. We can make one right there, and we can make one right there. And the other points don't work, so we had two there. And these points are symmetrical to those points, right? So those have to be two. And yeah, those should be all of our right triangles, right? Wait a minute. Uh, don't we count some of these like twice and stuff, Bill?
Mm, I think you counted some of them twice.
Yeah. Uh, actually,
So you should have 12 right triangles and 20 triangles in total.
um,
Because, if you look at each
okay, yeah.
side,
So the total triangles is obviously 20, right?
yes,
Like, so without loss of generality, 1 point, and then you have 5 points, and then you have 4 points. So that's 5 times 4, or you can do just six to choose three, and it's all 20.
yep.
How many right triangles are there?
Okay, so, look, for each side, there's two possible right triangles, right?
That is correct.
So there's six sides, and so there's 12 right triangles.
Okay. Okay. So every right triangle has to have a base of one of the hexagon sides, right? Um, the only triangle, so like this triangle, which doesn't have any base of the hexagon, it's not a right triangle. And the other one, this one has two, but it's not a right triangle either. And if you have a right triangle, it always has one base of the hexagon. So then you can just use like the sides of the hexagons to look at how many right triangles you have, which is like one here and which is another here. And that's all you have on this space. And you have 6 bases, right? And if each right triangle is classified on the base, then all those are distinct. So then it's 6 times 2, which is 12. So 12 over 20, which is 3/5. Um, my way was not as good. There was too many overcountings, or not? Yeah, overcountings. Um, I don't know. That would just be too messy. Um, I mean, I don't know. Maybe you could do it in that way, but it would be harder than just this way. All right, should we move on, or do you guys want to try doing it that other way, or what? Okay, let's move on. Yeah, the answer was 3/5. All right. Kai has 100 identical blue rods, each of length 3 inches, and 100 identical white rods, each of length 1 inch. In how many ways can Kai arrange these rods in order from left to right to form a row that is exactly 10 inches in length? Here's one such arrangement to include. All right, so the ways, like the combinations that Kai can have is 3 blue, 1 white, 2 blue, 4 white, 1 blue, 7 white, and 10 white, right? So 10 whites, there's only one way to do that. 1 blue, 7 whites, there's 8 ways to do that. It's like putting 1 blue and 8 blanks. Putting 2 blues with 4 whites, then it's just what? It's 5 choose 2. Um, is it 5 choose 2, Bill?
Uh, ba, ba, ba. It is. Oh, it's not five choose two because you can have two in one space. Remember, right?
Uh, uh, yeah.
I mean, five choose two is fine, but then you can also add like afterwards. You have to add the
Oh, okay, yeah. So you can do 5 choose 2 plus 5. Okay.
yeah.
So like it's like you have 4 whites, right? And then so you have 5 blanks to put the blues in. So if you're looking at separate blues, then you can choose 5 blanks out of 2. What? Choose 2 blanks out of 5, and that would be the 2 that you put the blues in. But you also have to account for what if you put 2 blues in the same spot? Well, then you just have to add 1 for every one of those. So you have to add 5. Okay. So that's just 15. And 3 blue and 1 white. Well, that's just 1 white putting in 4 blanks, so that's 4. All right, this is just 28. That should be your answer. Yep, that's your answer. 2 of the 8th grade classes at Prime Middle School took a math test. Class A had an average of 84%, and Class B had an average of 90%. The average for both classes was combined was 88%. If the total number of students in the two classes was 48, how many students were in Class A? All right, so you can do this in a very systematic way of saying Class A students, the number of Class A students is A, and the number of Class B, or the number of students in Class B is B. So then you can set up equations. You can say A plus B is 48, and then you could do the 0.84 0.84 times 8 plus 0.9 times b over a plus b, or that is just 48, right? Over 48 equals 0.88, right? So this is weighted average, right? Weighted average is pretty easy. And then you can just solve that. That's just system of two equations. So yeah, you could totally do it like that. There's also a cooler way, and it's also faster. So we have A here at 0.84, right? And we have B here at 0.90. And the weighted average is 0.88, right? This is 0.02 away from B. This is 0.04 away from A. So what this is saying is that the B students has to be weighed 2 times as much as the A students from our 0.04 to 0.02 ratio, which means that there has to be 2 times as many students in B than in A, which means that 1/3 of 48 will equal A, which means that A just equals 16, which is our answer. And that is our answer. Weighted average is just like whoops. Uh, it's like it's like it's like well, let's say I am Austin. Or not let's say, but that I don't know. I am Austin and Bill is Bill. Okay. So let's say I have
Whoa, we're
taken
perfectly A and B.
whoa, that's crazy. Okay, okay. So let's say I've taken only 4 AMC tests over the summer. That's so bad. Okay, whatever. And Bill has taken 11 AMC tests over the summer. Okay. And let's say Bill got an average of I don't know, 120 on his AMC test. And let's say I got an average of 80 on my AMC test. Okay. So
Sounds
what
about
is
accurate.
sure. Okay. Well, what is the average of all of our AMC tests together, right? Um, so okay, so weighted average is saying that the average of our AMC test would be 4 times 80, so the number of my test times my average plus Bill's average times Bill's average times the number of tests he took, and then over the total number of tests we took. That's what weighted average is saying. That this is um like weighted average is just saying like a way to find the average of this, right? And you can prove weighted average really easily, because 120 is the average of Bill's test, right? So 120 is going to equal the sum of his tests. So I don't know, TB1 plus TB2 all the way to plus TB11, right? That's what 120 is going to equal. So we substitute into that. That's just going to be the sum of all of his tests, right? All of his test scores. And then mine is going to be the sum of all of my test scores. And then if we just sum all of our test scores and divide it by the total number of tests we took, that's just our average, right? So that's just, yeah. Yeah, it has a name, weighted average, but it doesn't really matter. I don't know. Yeah. Yo, Lishan says I would have gotten the 120s.
I'm
That
sad.
is,
This is so sad.
yes.
Lishan, I'll have you know I scored higher than Austin, so
What?
I scored higher than you on the AMC, on both AMCs, so
Like, barely, like
okay.
6
I
points.
was the one that qualified and you were the one that did it.
Okay, shut up, shut up. Okay, let's just move on. Let's just move on. Let's just move on. Coco makes several lists of numbers using the following process. The first list of numbers contains one copy of the number 1. After that, when making the nth list, Coco writes down the number n and then writes the previous list as the terms that precede to n, that precede n, and again as the terms that follow n. The 4 lists are that. So how it works is list 3, you're going to put 3 in the middle, and then you're going to put the previous list there and previous list there. What is the sum of all the numbers in list 7? Okay, so to find the sum of a list, you just take the list number plus 2 times the sum of the list before it, right? So you could just keep like applying that, right? So you could see that list 2 is 4, right? So list 3 has to be 8 plus 3, which is 11, right? So list 4 has to be 22 plus 4, which is 26, right? And then you just keep applying that. So list 5 would be 2 times 26 plus 5. List 6 would be that times 2 plus 6. And list 7 would be that times 2 plus 7. Okay, so what is this? And you can just solve that. That's 52 plus 5, that's 57. That's 114 plus 6 is 120 times 2 is 240, and plus 7 is 247. See, not too bad. I just did that in like 20 seconds. I know. All right. Could you do it in other ways? Probably, but this is really simple. So I don't know. I don't really care. It's just 247. All right. A parallelogram is inscribed in an equilateral triangle with 2 vertices on one side of the triangle and 1 vertex on each of the other 2 sides. Oh, this is a spicy problem. If the equilateral triangle has side length 12 inches, what is the greatest possible area of the parallelogram? Express your answer in simplest radical form. Okay, so we have an equilateral triangle. Okay, let's make this our last problem of today. Okay, so we have a parallelogram inscribed in an equilateral triangle. It's going to have 2 vertices on one side of the triangle. Let's just make it this side. And 1 vertex on each of the other 2 sides. Like that. But it has to be a parallelogram. And the side lengths are 12 inches. Why is my drawing so bad? Okay, the side lengths are 12 inches. What is the greatest possible area of the parallelogram? Express your answer in simplest radical form. All right, this initially seems pretty bad, but I don't know. It's all right, I guess. So let's think of the parallelogram, right? So its 2 sets of sides has to be parallel, obviously, right? It's one of its sides is always going to be this base of the triangle, right? Which means that the other side always has to be parallel to this base of the triangle, right? Now, think about what that means, right? That means that the parallelogram always has to be a rectangle, right? Because, like, if this side is parallel, then, like, you can't have it slanted at all, right? Oh, wait. Yeah, you can't have a slanted. If you have a slanted, then like the points, this point would be higher and this point would be lower. So then it's like that, and then it's not parallel anymore, right? These two aren't parallel. So it always has to be a rectangle. So now we're just looking at, we're putting a rectangle into an equilateral triangle, and how big can the area of the rectangle be? I'm going to show 2 ways of how to do this. So one way is we can set this length equal to x, okay? This length right here. So then we know that this length right here, or I don't know, we could set this length equal to x. It doesn't really matter. So then this length has to be 12 minus x over 2, or it's just going to be 6 minus x halves x over 2. 6 minus x over 2. Okay, that's what this side is going to be, and what? And oh, okay, yeah. So whoops. Oh man. Okay, we know that this angle is 60 degrees, right? And this has to be right angle because it's a rectangle, and this is 30 degrees, right? So that means we have a 30, 60, 90 triangle right here, which means that this side is going to be 2 times this, or 12 minus x, and this side is going to be what? It's going to be 6 6 minus x over 2 times root 3. That's okay, yeah. And then what's the area of the rectangle then? The area of the rectangle is just x times 6 minus x over 2 times root 3. And we're just looking to maximize this, right? And this is just a parabola, right? That's going down, right? So it has a maximum. So we can just find the vertice of this parabola, and that y value of the vertex is going to be the maximum value you can have of this, right? So if we expand this, we have 6 root 3 times x minus root 3 over 2 times x squared. So the vertice x value is going to be negative root 3 over 2. No, sorry. Is going to be negative 6 root 3 over 2 times negative root 3 over 2. This is just from the vertex. The x of the vertex is negative b over 2a, right? This is equal to 6. All right, and then we can plug in x into here to find what the y value is, and just to find what the value of this expression is, right? Because this expression is actually the area of the rectangle, right? Okay, so if we plug 6 in, we'll get 36 root 3 minus 36 root 3 over 2, which is just 18 root 3, because this is 18 root 3. So then that's just our answer, 18 root 3. Now I will show another way to do it. So we have the equilateral triangle here, right? And we have a rectangle on it. So if we divide the triangle here, we can think of maximizing the rectangle as minimizing the areas of these two triangles, right? Now, where is the areas of these two triangles going to be minimized? Well, it's going to have to be at the midpoint of this line, right? Yeah. And then you just know that this point is at the midpoint of this line. So then so we know that this length is 12, right? So we know that this length is 6, right? If this is the midpoint, then this is going to be 3. So then this is going to be 6. And then you can just use the 30, 60, 90 that we still have to find that this is 3 root 3. And then you just multiply these together. That's 18 root 3. All right. Any questions on that? All right. If you guys don't have any questions, that's going to be all for today. We'll continue this national sprint on next week.